we'll not have quiz right away, rather we'll have quiz maybe next week. It would not be justified for many of you to have the quiz before the session. We will have, we most probably will be having class on Wednesday next week, maybe on 10th, I guess. Tuesday or Wednesday, 10th, I think he's giving me class 10th or 11th. So we'll schedule the quiz with the next class, right? So we are starting at 4:30, so we'll wind up at 6 o'clock. The session for today only. Quiz will have on again along with the next class. So somewhere we were talking about Arima, and how many of you can I get some quick response on the chat window? How many of you are using eViews right now? So that if I ask you to do it along with me, and I believe that some of you are doing it. How many of you are doing it? How many of you are using eViews? I've got 2 yes, 3 yes, 4 yes. Good, great, thank you. This much is enough. Even if 50% of you are doing it, means my job is done. So thing is that as we normally say that the taste of the pudding is in eating. So unless until you do it on your own, you won't get the pleasure of learning. Looking at the discussions, I don't think so it would do anything, any justice, any learning, unless until you do it. So we are going to recreate what we were doing yesterday. Yesterday we were talking about Sensex, and I gave some thought to it, and then I decided that it's better to do some manipulation on Excel. It had always been my policy to use Excel along with the softwares, and it works. Still, I'm finding that it will work. Assume that if I create one more, let's say a copy for you, then let me and I'll lock out everything. So nothing is there, so that you do not have any let me delete it. So we'll start from the scratch practically, so that you're confident that there's no advanced work which is done. So we'll do it with you. This is fresh sheet. And if I look at the data, then Sensex information is there with me up to 3rd October 2020 when I downloaded this from Progress. And the job which I have is to forecast it for next 3 periods. Whenever we do forecasting as a normal wisdom which we share, that looking into future far off is not a great strategy. Near future forecast is always more reliable as compared to far future. So that should be avoided. So that's why I'm just giving you idea about 3 weeks. Up to this I have got data. Let's forecast for 3 more weeks. So I'll be very careful right now, so that you should build the confidence that it is as easy as it is going to be today. If you look at the observations weeks, so precisely I've got 262 weeks data. Precisely 262 weeks. So I'll be noting it down also. And this is today is November 5, 2020. So we have got total observations 262 is the total number of observations we have, and forecasting period where we are having 3 weeks. So total number of when we are using the eViews, we would like to have we have to give that how many observations we are planning. So altogether these two comes out to be 265. This is the one precaution which we should take in the very beginning when we are actually going to use the time series for forecasting. Precisely this much exercise I am doing for forecasting, because theory will not be repeated it all the time. Theory is one time. You learn it, that's it. As and when you have got any question which may be answered with the help of theory, you go back. Else, what do? You make use of the knowledge. So ARIMA is a tool which can be used quite frequently to forecast. And that is what our purpose is. So we have learned whatever we wanted to learn in terms of theory about ARIMA. Today we'll only make use of ARIMA for forecasting. So keeping that clear-cut purpose in mind, what I am saying that when you have 262 observations and you have decided that you would like to have 3 more period as forecast, then altogether you need observations. When you are having one worksheet in eViews, you should have 262 plus 3. So as I'm counting it, this is 265. So I'll use eViews and I'll go for a file, new worksheet I'm creating. I'm giving the observations 265, precisely 265, 262 observations I have, and I want 3 period forecast. I've got this ready with me. I'll go for quick from Excel, and as normal style, we'll take the name of the field also. These are 262 observations. And that's it. So we have got a series which is having 262 observations. And first thing first, by the time you have got one time series, the first thing which you need to test is the stationarity. We have discussed in detail yesterday. Stationarity is something which we have to test, and null is time series is not stationary. Time series is non-stationary. This is the null, and alternate is time series is stationary. So this is the pair of hypothesis when we go for unit root test. So this is the very beginning. Yesterday we have tested and we have found that time series sensex per se. Click it, go to view, select unit root test, standard unit root test. Let all the remain as it is, and we have found that null cannot be rejected because p-value is more than 0.06, 0.05. So null cannot be rejected. So time series is non-stationary. Null cannot be rejected. So the alternate option will go for standard unit root test. We'll check at first difference, and what we are finding that yes, it is having the stationarity. So what we are concluding that sensex is I1 if I start the language of integrated. This is integrated or stationary at first difference. So that is the vocabulary which we picked up yesterday. We are just following the same. So it means if I want to use sensex, so I will be doing something like that. Value of sensex, value of t minus value of, or rather make it this way, t plus 1 minus t. For example, the difference 1 can be v2 minus v1, difference 2 v3 minus v2. So this will be the new series, which is nothing but the difference of sensex series. I hope everyone is clear what I am exactly saying. We have just tested that sensex is a sensex series is stationary at first difference. So to manually generate, this is the idea. When I say first difference, what we are doing, V stands for values of sensex. So second value subtracted with the first value will generate first difference series. Similarly, D2 and like that. And if we are too precise with the numbers, obviously we will be having 261. One will be knocked out because of difference. 1 degree of freedom will go away. So yesterday when we were running ARIMA through automatic ways and manual ways, that was the problem because first item was missing. So right now we'll be more careful not to let that kind of situation come again. So this series is stationary. So sensex is I1. So I can say that Sensex non-stationary, but D-Sensex is stationary. So it means I have to make use of stationary time series only. So as and when you are having any time series which you would like to forecast, the first exercise is you check stationarity the way we have done in non-likelihood 95% cases, you have to take the first difference. And I have discussed with you, this is the approach, this is the method to take the first difference. So we can do this on eViews, but again, the first row will be blank. So just to avoid that situation so that the results remain consistent and you have the comfort of forecasting. Because you should remember when I'm saying that we have to forecast, we need not do anything else. We have to forecast this. So it would be much better that we generate on Excel and then we take the data to eViews. So DSEN6, I'll create here following the same definition. The definition I gave V2 minus V1. I'm putting intentionally instead of starting from the second row, I'm starting for the first row so that I do not have problem of first value, because when model is run, it becomes important that what is the first value. If first value is missing, then it creates trouble. That was the logic yesterday we had discrepancy in manual way and automatic way, because definition of first item was taken differently because first item was missing. I have to just drag it. And if you look at, as I've said, you will find that last item is practically minus of this. And this item is not there. So that's why it is showing you as it is the last item, but in minus. So it's better to remove it. So this is the situation what you have. So practically what is going to happen if I still forecast, I mean, if I use not the Sensex, but D-Sensex. So if I forecast for 3 periods, I can go for 4th period also, but that will not be, giving me additional value, which I don't want. I want 3 only. So it is good enough for me. I can go for one more, but that is superfluous. I need for 3. That's it. I'll stick to 3. So these 3 will come as a forecast for this. And from this we'll generate that. That would be only a fraction of second. So first thing first, we'll first of all see that this time series which we have just made out of the main time series, first difference, we will randomly test whether it is having the feature of stationarity or not. So we will close the group, and this is the series. I'll rename it. I'll call it D Sensex. And I've got D Sensex. Okay, I have to just give some different D. Now here we have D Sensex. I can open both together. I can show you same thing the way we have. We are getting values there. We are having the same sort of value. And last value, as we have seen that it is, it has gone one step ahead. Why this is having this issue? I'll delete the both and I'll take the fresh one so that no problem of estimation. I'll correct the name so that I'm just putting the values of both the time series, and if I right now show you, then you'll find that things are as we wanted them to be. So D-Sensex is having one value less, and NAs are there because we have allowed eViews to have the observation up to 265. So We will quickly check whether this first difference series is having stationarity or not in levels, and what we are finding, same idea, is D sense X, which is the first difference of sense X, is having the stationarity feature. So yesterday after testing for stationarity, we can say we have done this thing first, then we have tested for stationarity, and we have got the series ready, which we would like to use for forecasting. And third, we are going for ARIMA forecasting. So first of all, we have to make the ARIMA model. To make the model, we have to, the biggest task in ARIMA modeling is to identify what is P, D, and Q. So right now we do not have ARIMA, rather we have ARMA, because we have already known that this is one. All these are theory which is not desired. But right now what I'm trying to pinpoint is that we need to know what is PQ. To find out D was easy, but to find out PQ, again we have very large theory, many supports that this is the way, that is the way. You might have heard, if somebody would have read some literature on that, you have got autocorrelation function, partial autocorrelation function, and then we say that the order of AR part of ARIMA model can be decided with the help of partial autocorrelation function, and the order of the moving average part of the ARIMA can be found out with the help of just autocorrelation function. So all those things are very complicated for quick forecasting of the data. So in a way, what I have found, and I still have checked, exchanged notes with people, then we have found that this is one of the best way that you straight away make use of this automatic ARIMA forecasting. Though we are not interested in using this for forecasting, rather we are using this to get to know what is the appropriate order of P and Q for ARIMA forecasting. So unless until we have got a right model, we won't be able to use it. So just to know right P and Q, if I insist, there are practically, as I was discussing, there are, I could say there are 5 items that we need to have, which we won't be doing it all the time. Rather, we have got model one. Model means when we have P1, Q1, model two, and when we have got P2, Q2. I'm saying that, yesterday we had 4, 4, 0, 2, like that. I could have 2, 3. So I'm using, yesterday we were talking about ACAC information criteria, Schwarz information criteria. So usually these two are the information criteria. So you can look for least here, least here. If both are same, no problems. If both are different, then you most of the time you have to. Then when I say the logics which we look for to identify the best model, first can be that we look for a number of significant X or exogenous variables. Then second could be, we have got error variance. I'll tell you where I will get the error variance. And third is R square, which we know very well. Error variance, I'll explain what exactly I refer to and where will we get the error variance. And then we have got AIC and SIC. So this is the 5-point summary which we need to develop to identify the model. So rule I'll discuss with you what is the rule, and accordingly we'll take a call which model even out of these two is more appropriate. So when I talk about this higher is better, higher number of significant independent variables in a model is a better model. Error variance should be least. Error should always be least. R square higher. AIC lowest or lower, and SIC should also be lower. So these are the 5-point summary and their criteria which should be used to take a call. So if you look at all these 5 items together, then you can very easily conclude whether this is good or that is good. And accordingly, you should go ahead with the final selection. That is second level. I won't recommend that all the time you do. Right now, we'll only stick to the automatic ARIMA forecast configuration. And obviously, as we have understood or seen yesterday, that it is going to use only one of them, or rather, it will give you a table. You can take your own call. So, theory or literature supports that you can always rely upon ACAC information criteria to take a call. So the model, instead of going for autocorrelation function, partial autocorrelation function, and making things very complicated, straight away go to the main thing. I'm not saying that is the best way, but in the given situation, the solves are many problems. So with the help of computing skills of computer, we are making use of this table, and straight away, instead of using all the 5, we'll be using this, and we'll be taking a call at which is the most appropriate model. But for further refinement, when you want to upgrade your model, you want to have the best, and you have plenty of time, then obviously you can have a few competing models. A few competing models can be generated from looking at the graph, which is the traditional, conventional way, which we are not touching even. And then we can use for this these 5 point summary, and we can come out with the idea that out of, let's say, we have got 4 or 5 models, which model is the best that can be chosen. So right now won't be wasting that much time. We'll straight away go for running the automatic method. And as I suggested to you, don't go for auto transformation. Otherwise, it will auto transform, take the difference, take the log, or any other thing it can do. So just to avoid, give the command none. And here you can request for the ARMA criteria table, and rest you can leave. By default, it selects, but it gives both CAC information as well as choice. As I run, I've got a table, and yesterday also we have seen 4, but right now we are getting 4, 3, and we can note down the value, and you will find that more or less very close same value will come. So the suggested model is coming out to be ARMA. If I write down, and I can write down ARIMA also, the same thing, 4 comma 3, this is the coordinate. Here I can write down 4, 3. So this I'm getting with the help of automatic ARIMA model, and I'll write down the value AIC 16.1054. So 16.1054. So the manual table should give, or manual model should give AIC very close to this, or even this. That's not a problem. Class, you are with me? So far, so good. No issues.
Yes, sir.
Yes, sir.
So we won't miss out with our objective of forecasting this. That is the goal. So for whatever I have said, that is all fact, because when you are quickly doing it, you will do at a stretch. You won't talk this much the way I'm talking. So we are going to estimate using manual ways. So the purpose of testing the automatic ARMA model is just to get this. That is the only, I mean, just to get this. That is the trick, nothing else, no other purpose. It's not going to serve anything else. We'll be following our conventional way. We'll go for estimating, and we have got the model. We'll close this. D Sensex is the name of series. So D underscore Sensex, and then AR124. The way I was writing, MA123. So if 4 is the coordinate or odd of AR part of ARIMA, so all has to be estimated. First leg, second leg, third leg, and fourth leg, similarly for moving average item. And we are only going to say this. This is the error variance. This is, we are not talking about this error variance is slightly different. Let me give you, increase your GK practically. If you remember, we have talked about this error term ET, and I said that moving average is a lagged value of this term. So what happened? Technically, when we say this is a white noise term, then the variance of this should be constant. Variance of this is nothing but it should be, I mean, it is shown with the help of error terms, it should be constant, and that is nothing but the error variance which we are right now talking about. At some free time, I'll show you if I have to generate some random terms, I can generate with the help of Excel, and that time I need to give this as standard deviation because when we are running any normal distribution, then normal distribution, if you have developed that much GK, I'm giving you some passing information which is not the key information. So any normal distribution is no like your name and course which you are doing in a symbiosis. So you are doing MBA in IBM Pune. So these are like coordinates for you. Similarly, for any normal distribution, the coordinates are mean and standard deviation. So if you know these two, you know what is the nature of a particular standard deviation, normal distribution. So these two are the coordinate of any distribution which is normally distributed. So all the members of normally distributed distributions are differentiated by their mean value and standard deviation. So this, it means the point here I'm trying to tell is random number can be generated combining the concept of normal distribution and random number. And when I'm interested in using the normal distribution concept to create the random numbers, I need to have the variance. And practically I can get to know the term with which, the MA term with which my ARIMA modeling is constructed, what is the variance of that random error term. So that is estimated. So this practically you are not going to use anywhere, but it's good to know this one time. So this is sigma, this is variance. So this value, what I am saying that this value should be least. This 534.123.9 should be least when I was talking about error variance. So these values will be written here, and the model which has got lesser value of this error, that should be chosen as a better model. So again, these are not, this discussion is also not relevant when we are actually doing the modeling. Look at this value, as I was saying, the 16.1054. Yesterday we were in a fix just because the issue of first term was there. So 16.1054, 16.1054. So now, as you are finding theory, what we got the least value of AIC in the automatic model and the manual, both should match. That is the purpose of using the automatic. So automatic, whatever value, the value of AIC, the criteria which was the least value of AIC should also be least when we are running the same model of same coordinates or model of same order, then AIC value should also be same, almost same, and it is same. So again, we are not going to do anything with this model when we are just quickly running or using the data. After all, we have to just forecast. So to do that, so quickly, we have just got, as I move the next series, you will realize that it won't take even this much time. So here I have to go for forecast. I have clicked it automatically selects some number and you can say, you can forecast, you can give this name, any name of your choice. And what happened, this forecast sample, don't want other numbers to come, you can remove, insert actual of out of sample observation, that also you can remove so that you have very neat situation. And forecast sample which you want to forecast, that you can give 262 on there. So you will say 261 to 260 practically 4. So we just want, you remember we had 262 observation, one was knocked down, was removed when we calculated the first difference. And so if we want 3 items for forecasting, so we want data only up to 264. As I click, I have selected dynamic forecast. The logic for dynamic and static is, dynamic means when I'm using some forecast value to forecast the next period, I won't be able to generate 3 forecasts unless until I follow this rule. So static forecast won't give me that much power. Static means use only the actual observations. Don't use forecast value to forecast further. So that's why dynamic means it is using the forecast value to forecast for the periods. So it is better to take dynamic forecast. This you can minimize and look at the forecast. And as you are finding it here, it has generated the value for we have 260. Just let me see. This is the series we have used. D since X. This value why coming I'm unable to understand. That's not important for us also. We are going to have these three values which we wanted to forecast. That's super flat fluous value. I'll see to it where it is coming from. I'll correct that. So right now we won't concentrate that we didn't ask for also. So we have just looked for these three values. So we'll take these three values only. Up to this we have given data. If I show you, look here, up to this we have provided the data to the system, and these three we wanted to know, and these three we have got, and these are the forecast value. So we can copy from here as well, and we can paste it here. You can cross check whether yeah, the right values have come. So far, any issues to anyone? Any issues to anyone? Are you doing it together with me?
Sir, I'm not able to find that forecast tab.
Forecast tab. This is the forecast tab, and we run the model here. Don't delete. This is what we have run. Then here you have got forecast. When you run the manual ARIMA model, you will get this normal. This is conventional dialog box which is there. Go for forecast, do whatever you want. Done?
Yeah, actually, to the mistake, I did not run the regression. That's why.
No problem. No problem. So here we have reached. Now we look at, if you have seen this, I'll take you back. This was the way to calculate the values or difference. So I'll show to you. So it means I can say, I'm just using this expression. Difference is nothing but V2 minus V1. So it means if I want V2 value, next value which I don't have. So what we have to do, difference, which we have got with the help of forecast and V1. So I can say the first difference, first difference. So first difference is nothing but second value is nothing but difference 1 plus V1. If you can understand this way, you can understand without 1. Either way, it is okay. Point here is second value is nothing but the difference during that period plus V1. Are you with me? Guys, are you with me?
Yes, sir.
So if I just follow this rule, it means I am looking for V2. So what I have to do, I have to go for D1 plus V1. So you remember we have given the formula. If I just show you the formula, look at here. So this formula is this formula here, this here, and I'll highlight it so that you don't even out of confusion. This, if I show you, so this difference is coming, this is V2 and this is V1. So V1 plus D will give me this. That is the idea. You're there? So V2 is nothing but V1 plus D. I can show you here also. If I have to create V2, V2 is this plus the difference. So as you are finding that, this and this both are same. You're there? Clear?
Yes,
So
sir.
V2 is nothing but previous period value V1 plus the difference which we have generated using this approach. So following the same thing, nothing. I mean, what we are doing the same, what we have done. So I'll say V2 is equal to V1 and we'll straight away plain simple summation. Whatever is the sign, let it be. and I can, drag it, same idea. Even if you look at this, this is nothing but these two. So here I have got the forecast values. As I go for forecast of the next time series, I won't take even this much time, hardly 5 minutes are good enough. So point which I'm trying to make here is that ARIMA model, though it has got very long, troublesome, hectic, tedious process, but if you use the model with this only purpose of using the model for forecasting, then you can do very quickly. I'll show you as I move to the next time series to forecast. But I'll take a pause. Tell me if you have got any problems so far. So we had a purpose to forecast Sensex and we have done that. So anyone, and please, when you guys don't speak, then there are two things. Either you have understood or you haven't understood. I mean, either everything has been understood or nothing. So I know some of you are saying, yes, yes, you have understood. So the thing which remains is even the last one who have not probably paid attention due to one reason or the other. So I am trying to, ensure that at least if you are not clear, you speak up. I have plenty of time to answer the queries. Don't you worry. I can talk to you offline also.
So could you
So
show the
can
forecasted
I
values?
quite often, then I'll give you a chance to ask. I want other
Sorry.
people also to, contribute if you are not clear. Be ruthless when it comes to learning. Don't worry what anyone is saying or anyone is talking. It's your learning which is important. So if you're not clear, please speak up. Anything small or big. I don't discriminate on the basis of questions. Your performance will be reflected in the assessment component. I don't know even this online classes names we don't remember, faces we remembered, but now we don't even remember faces. We don't remember anything. So whether you ask questions, don't ask questions, that's not going to impact the marks. So when you are learning and you are not clear, please ask questions. Don't worry for anyone. All of you are completely clear?
Sir,
Yes. Go
so
ahead.
when we get ARMA model instead of ARIMA,
Mhm.
so does that mean that the dataset does not have a problem of stationality?
You know what happened that when we are having a time series, usually financial time series will not be stationary in level. So 95% times you have to take the first difference and you'll find that it has become stationary. So we handle the problem as per the case. When we know this in advance, that we have to ultimately handle a non-stationary time series in first difference. So the trick which I'm suggesting, use it. Don't run the non-stationary time series, rather out of the system. Out of system means out of eViews or Stata, you convert the first difference time series yourself manually so that you have comfort of making use of forecast value of the stationary time series to generate the value of non-stationary time series. So this approach which I'm using is more handy so that you can have forecast values of the non-stationary time series in no time. So I'll suggest this way. But you know that the real coordinates or order of the ARIMA model is not 4-3, it's not ARMA, it is all the time ARIMA. So 4-0-4-1-3 is the right order of your ARIMA model. But that's theory. In practice, who cares?
Okay, but sir, still, if the value of D is equal to 0, then that means
No,
that
no.
the
But you know that you have been given a time series Sensex. So
yes.
you are making a model for Sensex. So what you can do at the most, if you are too particular about this, so that no, I have to, be very clear what exactly I'm doing. So don't worry, you have got Sensex, open it, and
Yeah, so
then
estimating
you run it, you will get, and then go for auto. And here you are getting D log, look what they have done. Automatic series is suggesting that not only take the difference, but convert that series into log series and 4-3.
okay, okay.
So ultimately you go this way or that way. So, but this is theoretically great that you have got, coordinates right away or understanding. But when you want to run this, then you will be in much more problem as compared to the method or the ease of computation which I have suggested to you. That's much more easy for you. My mind is focused that if you really have in real life a time series and you quickly want to use ARIMA for forecasting, what to do in the shortest possible time, putting least efforts, then that is what my approach is. I'm trying to strike a balance between theoretical clarity and ease of or comfort of doing it practically. No issues. Whatever you have said, I have shown to you.
Okay, well, got it, sir.
Great, great. I appreciate people ask questions. Please ask. Okay. So we have done, we have got the forecasting. I did it yesterday. So same sort of values are there, but slightly different values are there. So I might have done some other issues, no problems. So here we have got, now we are going to have one more time series. If you remember, in some other cases we have talked about all these four, I think in the FM course we were doing. So DMART, SDFC, RIL, TCS, we have got stock price. I'll take RIL. I'll take RIL, and again, I think the number of observations are more or less same, 262 observations. So I think I guess I can make use of this worksheet. So my goal is, please pay attention. My goal is to forecast, and don't think that EViews only can generate three forecasts just because I'm doing it three all the time. Don't get this learning. Like you're starting, no, EViews three times only. No, it's not like that. It is indeed more than that, even one only, even also. So I'm just going to have again forecast values for 3 time periods. And here I'll first of all check whether it is having the stationarity or not. And on all likelihood, we understand with our previous knowledge that time series stock financial time series are usually non-stationary in levels, and level I'm checking and I'm getting this 58578, which says that model is not the time series is not stationary. I'll quickly check here itself. I'll check at first difference, and here it goes. It is showing that it is stationary at first difference. So situation in terms of stationarity is not different. It is same what it was in the case of Sensex. So as I have suggested to you, we will go for calculating DRIL. So I'm going to calculate DRIL, same approach. This V2 minus V1, same approach. And right now I have to just calculate. And as I know that this value will be again same, but with the minus sign. So I'll remove it and I have a different series ready for me. First, a different series of RIL is there with me. And as I have told to you earlier also that I want just 3 observations here as well, so that I can make use of to generate 3 forecasts. I can do for 5, I can okay with the for one period forecast. Again, these are weekly time series are there. So now here I've got, now you can start having the stopwatch if you want. It hardly going to take 5 minutes. So I have to create DRIL time series in eViews, and if I'm too much curious to talk about stationarity, I would go for level, and here it is. So non-stationarity null is rejected, so I've got this time series is stationary. Again, I'll go for proc automatic. Purpose of this automatic ARIMA forecasting is just to get to know the orders of MA and AR part of the ARIMA model. And here I have got, I could have table also, but just skipped, so skip, no problem. Look at this is saying that 0, 0 model is the best model. So in itself, we are finding that it means just random number will be the right model will be having the least AIC value. So we will be having that. So 0, 0 model, if I have to run, I guess it should work. Let me hit and try. TRL, yeah, CAR 0 if I put, I don't know that will estimate or not. It is not estimating, so it means this is going to be, if I manage, I have to again check. It will give the constant value. This is the forecast. It is giving me the constant value. So, I mean, keeping that in mind, we can say right now the suggestion given by automatic model is not very great. So we are stuck due to this reason. Yeah. Let me have the table also, if I may get some help out of it. Otherwise, I'll quickly move to other time series to forecast if it is not serving the purpose. Proc. We have gone from this. We'll look for table. Something is wrong. So here what we are finding that it is still suggesting same 0, 0, and this is the least, undoubtedly least value. Do I get some solace? Technically, if I just follow AIC, then, but this is not giving me any model as such. It is just giving me the constant value for the. Even this is giving the least, so RIL value is not very well modeled with the help of ARIMA. That conclusion we can draw, nothing else. It will not help in any way to have the forecast value. So we'll try another if that can be quickly done. TCS, DTCS. I'm trying out another time series because that time series didn't help us much. It is just giving me a constant as forecast, so nothing great. So here we have got, and we can just check. And as we have understood that it is having the stationary, when we have got T series in first difference, then go for ARIMA, go for none option. Let's go for table also. And see, now it has got 1, 1. So as per the model AIC value, we'll check users randomly. Just have a look at what is the value 12.6996. If I have to manually estimate it, so I'll say that DTCS CAR just one MA, only one, and here we go. So it has estimated, again, we are not going to do anything. We'll straight away go for forecast and we'll say that we are interested in 261, 264, 34. So that was the logic. 234, we want 3. We are removing this. Simple. What is the problem? Mm, 2, 260, 234. Due to missing data, where the data is missing. Two 61, 234. Which one? Message is coming. Oh, something is happening which I'm not following in this data. This is not giving the accurate estimates. Something is somewhere I'm committing some mistake. I don't know. So it means we are going to test the third time series. Okay, let's do it. You guys are there?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Good, good. Let's see. Let me try it out. Why it's not looking up. Something was wrong here. Yeah? I hope it should not create trouble. It's okay. So this has given 2 as the right model. We'll go for manual estimation. DH, BFC, AR 1, 2, 2, MA 1, 2, 2. And if we go for this, class sample 261, 260. What is the issue here? I'm doing some mistake. Something I'm doing mistake which I'm unable to identify with these data. It means something is wrong with this data which I'm using. Is the data in order or not? Data seems to me perfectly alright. No missing value anywhere and such. I'll see to it. Let me try the third. We have more time series at least. I got some data of foreign exchange reserve. We'll try to forecast this. I'll get back to you. Obviously, it has got some or the missing values. I haven't tried the data. ठीक है, we'll use this much. We are having the foreign exchange reserves in India. Again, I guess we have taken the data weekly. Let's take the dollar million values, and we have got how many observations? Quite less number. Let's have more. चलिए, ठीक है. Now we're getting 498. So 497 observations. Let's say foreign exchange dollar. 497. We'll go to e-views. And close this. 497. Empty series. And we can see, I don't know, usually it should come non-stationary, but it is stationary in levels. Great. So foreign exchange time series is coming out to be stationary. So we'll be running the ARIMA here itself. And again, we can say we would like to, let's say we'll forecast 2 periods only. And you have got data you can compare. Rock, go for none. We'll go for table. And here the model which is suggested having the least AIC value is 34. 34 will estimate an exchange dollars CAR 123 MA 124 And here we go, we have got forecast value and one mistake we have done. We have got data for, as we were saying, data is for 497. We'll take at least one 498. So time series should be accordingly, the worksheet should be generated accordingly. So we'll not have 497, rather we'll have 498 observations. So one space for creating the future value, or we can have, let's say, 498. So we'll have 499, 497, 499, 497 observations to forecast values. If it doesn't work, I'll start the next topic. I'll rectify the problem. Talk to you next time. Last attempt. We have left two. We'll quickly check. It has been stationary and levels. It is there. So non stationarity null has been rejected. So time series is stationary. We will go for proc. Generate the table, and here we go. As it is showing me 3 4, it has not changed. So the best time series for ARIMA forecasting is having the configuration of 4 AR term, 3 AR term and 4 MA terms. So DC AR 1 2 3 MA 1 2 4. And we'll go for forecast. We'll say we are interested in 498 and 99. We can remove this, and it seems that it should provide us. This is the value, that is the time series. We can open both together, and here there's no problem of calculating the difference values. Straight away we can say that these are the values which are coming for forecast. You can compare also these two 041. So these are the forecast values. As you can compare with them, these are the actual values and those are the forecast values. There are differences, they will remain, but this is the again. So it means something is wrong with that whole data sheet which I have got for stock market prices. I'll correct it, don't you worry. When I meet next time, I will I would have corrected that, and I would have discussed with you what's wrong. So seemingly we can say that ARIMA model, the concept, today I told you this much thing. If I say that where we started today we started from where is it? Yeah, here we started. So we said that if we want to forecast, then we should have that many vacant observations in the worksheet when we open the views. So 262 observations were there in Sensex data, 3 we kept 3, so 265. Then we tested the stationarity. Now we have tested stationarity for so many times. First difference story I told you so that you can easily use first difference time series having the forecast values which you can use to generate the time series forecast values in levels, the way I have done in Sensex. And then I told you to just to know the order of appropriate ARIMA model, we go for automatic method available in eViews. And I also told you that if we have competing models, which we might have, we use both. Probably at times we find these two, or if I just refer to the conventional method of going for EMA modeling, then I have to practically look at autocorrelation function and partial autocorrelation function, and then I look for the significant values, and there I would have got some competing models. Then when you have to take a call among the competing models, then these are the methods. Number of significant independent variables, error variance value, R square, AIC, and SIC, and accordingly I have given you the criteria. And then I had a discussion on ARMA, as some of you asked. AIC purpose of AIC is that lowest AIC value is the appropriate. Then I told you what is this error variance. The MA has got a random term, the constant variance, because this is a white noise process which has got it's a stationary time series. Random number should be stationary. So the variance of this random time series is known as error variance. And I have tried to quickly tell you how to do it. We had some problem in stock pricing forecast and rectify. I'll get back to you on that again. I would just quickly show where the mistake is and how it could have been done. That's it. The topic is practically over, barring that thing, which will be the first discussion point for next class on Friday when we, the Tuesday or Wednesday when we meet next time. So, anything from your side, or shall I start next topic, VAR?
Let's start next topic.
So we are starting next topic. Wow. First question first. How many of you have another thing which is something shown by this? Anyone? Just question of GK. GK from the financial point of view. Have you heard this term before? Seen? V caps, A small, R cap.
Yes, sir.
What is that?
So the maximum loss that we can bear, like something related to that.
Perfectly all right. This is, when I say a risk, then obviously one of the most elementary discussion is sigma. Sigma is the deviation of values from the mean, is the estimate of risk. VAR is also one of the tools to measure the risk. It is known as value at risk. Value at risk, and as a matter of convention, it is written this way, VAR. So where for stock market, especially when derivatives are traded, then risk goes up. Then instead of relying upon plain simple sigma, people rely upon VAR, and they get to know how much money should be kept as margin. In India, J.S. Verma, he has started this, he's still professor at IMA, and he was in the advisory committee of SEBI as well as from the stock exchanges side when early 2000 or late 1990s when we were talking about introducing derivatives in India in 1996. We have got Depository Act, so dematerialized stocks. Then only these issues came into picture. What would be the right margin if derivatives are traded in India? So we started with futures, then options, and all those stories. So VAR was decided as a tool for measuring the risk. But this VAR is not that. This VAR, which we are going to study today, is known as vector auto regressive model. So this VAR is invariably written, this A is not small but caps. First difference, we had just finished ARIMA. If I give you what is the good and bad thing with ARIMA is that it is talking about YT only. It has not got any other independent variable. If you look at construction of ARIMA, so YT was nothing but constant alpha. But if I just follow the convention of using beta 0, which is the constant term, I said t minus 1. If I'm talking about, let's say, one type of ARIMA model. And then it has got coefficient will remain there, beta 1 plus beta 2 E t minus 1 plus E t. So that is something, this is the construction. If you look at this term, this is the random term. This is the auto-regressive term, means this is decided by its own lagged value plus some lagged values of the error term. There is no introduction, no discussion at all of any x other than y. So what happened when we talk about ARIMA, we undoubtedly call it univariate. First thing. This is univariate model, means yt is used itself, lagged values and some random error term, and we have done the modeling. So we are not using any other time series which might have some impact on the determination of yt. We are ruling out, we are saying that y per se is competent enough or good enough to tell stories about its own future value. That was the idea about ARIMA. But as we move from ARIMA to VAR, and remain the point of interest is forecasting. We are still more interested in talking about forecasting. VAR has got other utility also, but mostly it is used for forecasting. So this is univariate. On the other hand, this can be bi or multivariate. First difference. So I'm giving you some difference over ARIMA. The VAR, how it is different for ARIMA. So this is the first difference. If I just show you, now when we talk about VAR models, then we'll be having more than one. Y1, Y2 will have just two, or we can have three, so that you don't think that it is only bivariate. If you pay attention to my insistence on using Y, it means I'm saying that right now we are going to talk about a model where, if you have paid attention to regression, we always used to write this way: beta 1 x1 plus beta 2 x2. So as a matter of convention, we believe that x1 and x2 are pure exogenous terms. When I say pure exogenous, I'm talking theory, but they are good enough. At least for one time, that much clarity should be there. Pure exogenous means they are the cause which is impacting the y. It is not the other way around. It is not the other way around. No, it is not the other way around. That's why we are calling it pure exogenous. But there are theories where we are finding that y is having a relationship, causal relationship from, let's say, x1. But what is happening that x1 is also, x1 is causing to y1, but we have situations where y1 can cause x1. I give you simple example from the finance world. The stock prices, let's say volatility in stock market. So volatility, or let me put it by sigma, so that so sigma, let's say in stock market. So this is a time series practically, and then volatility is causing the impact on the volume of options. I guess you are clear with options futures. That much basic is okay. Yes, no?
Yes, sir.
Derivatives are derivatives which derive their values on the underlying asset. Underlying asset can be spot rate, or it can be stocks, it can be practically anything, any commodity, exchange rate, interest rate. So derivatives are a varied nature. So I'm giving you example where the volatility of the spot market or stock market is impacting the volume of option, and this relationship is typically other way around. This is well established relationship. That's why I insisted to show to you. So if I happen to talk about this as y1, and this is, I'm bound to say not x1. In this construction, I can say when I'm talking about the first construction, when I'm talking about the first construction, this is first construction, this is second construction. In first construction, what I'm saying that the uh, I have to give some name also after all. Let me call it y1 and y2 if I call this way. So what is happening that y2 is the dependent variable and y1 is the independent variable. This is the construction. And in another case, what we are finding that y1 is the dependent variable. You know, y1 is the dependent variable which is being caused by y2. So whenever we get this type of situation, this is well-established fact. This is not the only one example which I has given you. There can be many more. So it means whenever we get this type of situations where in the equations with the variables in the equation are not pure exogenous, I mean they are not the pure independent variables. Rather, one time they are playing the role of independent right now in this construction, but in this construction, what is happening that y2 is playing the role of independent. Earlier it was dependent. So whenever we get this type of situation, we call it systems of equation. System of equations. So equation. So we are not calling just dependent and independent, rather we are calling system. So this is just nomenclature. One addition in the vocabulary. When you have got variables where the line between endogenous and exogenous are no more there, all are endogenous. Endogenous means independent variable. Exogenous means independent variable. So when the line between endogenous and exogenous are blurred, they can be used interchangeably in the system or in the situation. Then what do we say that that is known as system of equation. So when I talk about VAR modeling, in VAR what happened that we do not have anything which is exogenous. All the variables are endogenous. And whatever we make in a VAR model, that is systems of equations. We never have one equation in VAR. Why? Because VAR is not made by one independent and one dependent variable. Rather, VAR is always made by at least more than one variable, and both of them are supposed to be treated as endogenous. So that is one of the typical situation of using VAR model. So ARIMA was, as I was saying, it is just one univariate. But when we talk about VAR, it cannot be one. It has to be two or more than two, bivariate or multivariate. As I was saying that system of equation is VAR, but ARIMA is equations. Because in ARIMA we have got yt as a dependent variable and its own lagged values and lagged values of the error term combined, then it becomes the equation, ARIMA equation. It's not systems of equation. Rather, when we talk about VAR, then we have got systems of equation. Just nomenclature, nothing else. If I construct one, I have to construct all the three if I have one. So what happened? I'm just not writing down the coefficients, beta 0, I'm not writing, that is taken for granted, that is there. So what I'm writing that I'll be having y1t minus 1. Let's say I'm talking about the way we have talked about P and Q. P and Q were the lagged terms or order of MA and AR terms in ARIMA modeling. Right now we talk about lag term. And what happened, whatever is the lag term, let's say for argument's sake, right now I'm using 1. So this in systems of equation, every equation will take only one lag. It cannot take two. If you want to take two, then you have to take 2 log. Then all the equations will take 2 logs. So that depends how many lags we have decided. And determination of lag is one of the most important things. If you remember me clearly, when we were talking about ARIMA, our considerable amount of time goes into deciding what is PQD. Similarly, when we run VAR, purpose is forecasting. As I have given you quickly, we estimated ARIMA model. So quickly we'll be using a VAR model for forecasting. But the trickiest thing will again remain the same, that how to determine the lag. Basic idea will remain same, that we'll look for again information criteria. AIC and Schwarz information, AIC and SIC, to get to know what is the appropriate lag term of the VAR system of equations. So that basic idea will remain intact. And quickly, In no time, again 5-10 minutes, we'll be able to run the forecasting value using VAR. So when we are, VAR is advancement of ARIMA. ARIMA says, no, I'm self-sufficient, I'll do everything myself. VAR says, no, I will have at least more than one, or not one, I mean more than, not two, maybe more than two. And then I'll be taking a call whether a particular time series, the future value of time series will be decided. Let me complete the construction of this situation where I'm talking about only 1 lakh plus y2t minus 1 plus y3t minus 1. Mind you, we are having the equation of y1. So y1 is also be having there as we were there in ARIMA. So this is auto regression term is there, means 1 lakh of the variable which we are forecasting. And this construction, this portion is very similar to AR construction of ARIMA model. But rest of the terms are not error terms, or they are lagged values like we had in the ARIMA. Rather, we are having the lagged items of other endogenous variables. If I complete, I'm assuming that beta 0 coefficient of this, coefficient of this, coefficient of this is also here. Similarly, y2 will also have ditto same, only the coefficients. If I just write it. So if I write beta 0, so here I'll write beta 0 dash, and suppose here I write beta 1, I'll write beta 1 dash. So this is t minus 1. I'm writing so that you can have beta 2 dash again, y2t minus 1, here beta 2, and here I'm putting beta 3, and here I'm saying beta 3 dash, y3t minus 1. The common thing is these time series in their lagged, first lag, because we have taken 1 lag, so 1 lag will remain in all the equations. What is changing? Only the coefficients will change when we estimate the model. Similarly, here we have got y3, so beta 0 double dash plus beta 1 double dash y1t minus 1 plus beta 2 double dash y2t minus 1 plus. It may seem a little complicated, but so symmetrical that is not a big deal to have some understanding of it. So guys, are you there with me? This was the rough construction of VAR model, and as I have shown to you that we'll be doing it, I'll quickly show you how it can be estimated. So I'll make the best use of remaining 5 minutes, and then I'll use the same model to have the forecasting later on. Construction wise, any issues to anyone? Anyone has got any issue of systems of equation idea when we do not have one equation where we have some dependent, endogenous, independent, exogenous variables? Rather, we are saying no, the world is together. There's no differentiation, discrimination between a ruler and ruled, strong and weak. All are at par. And what we are saying that let's model them. That is something which is the idea about the VAR model. All are taken as endogenous. So let me, as I told you, I'll be again using this eViews. I think I must be having something. Let me find out if I have, otherwise I'll quickly copy paste. I'll show you one model at least. Here I have. So I just had in one of my research papers. I'll share with you that research paper also. So now when I practically run VAR and one advanced, which is next topics, co-integration and vector error correction model, that will be the next topic. So before I run, one more condition which I need to share with you, that whenever VAR is there to be run, we think or we plan to run the VAR, there are some preconditions. Precondition that all the Y's should be I1. If it is not there, we can't run. Simple. All the variables should be in their level, not stationary. But they should invariably be stationary in their first difference. That is the precondition to run VAR. And the second, when we run co-integration or vector error correction model, same condition prevails. So what happened if you have listened to me carefully when I say ARIMA? ARIMA ensures that the time series should be stationary. Only then it makes sense. So ARIMA construction per se converts the series into stationary, and then it models. But here, what is happening? Having a typical situation that the time series in level should not be stationary, but in first difference it should be stationary. That is the precondition. Second good thing that whenever we run var, we always run in level. These are typical mistakes which people commit. That's why I'm highlighting. The var, when we are having y1, y2, y3, or y4, y5, or only y1, y2. So what happened that all should be I1, means in level they should not be stationary, but in first difference they should be. So are you with me, all of you?
Yes, sir. Sir, I1 or T1? You said
I1,
T0,
I1,
T1 last
I1,
time.
I1. There's nothing T1.
Okay.
I1 means integrated of order 1. You remember we discussed yesterday
Yeah. Yes, sir. Yes, sir.
that you recall, huh? Integrated means
Yes, sir. I've
stationary.
written TI
Zero,
when.
I0 means stationarity at levels. So we can say fixed reserves, foreign reserves is I0, but Sensex was I1, or RIL time series, stock time series, stock prices were I1. They were stationary in first difference. So that is right. Any other question? And again, repeat, every one of you are important. It's not that those who ask question, they are the only important people in this lot. Each one of you are equally important. If you have any question, please ask. Don't let anyone else to take the lead. I mean, you are the boss for yourself. Ask questions if you have one. Okay, let me quickly show you. I have got BSc. I'm running unit 2 test at level, and this is not stationary. And I'm going for first difference. Going for first difference, it is stationary. Same I can do for, let's say, China's time series. All our original data, I've taken it from my own research work. This is not stationary. And if I go for first difference, it is stationary. Similarly, let me have Singapore Stock Exchange. I'm talking about the main leading indices of that country when I say China. So Singapore also same thing. Singapore Stock Exchange. It is not stationary at levels, but when we are going for first difference, it is stationary. So I'll use only these three: BSc, China. I'll select all of them. I'll go for right click, open, and here I get one option open as var. I'll go for this, and I can, increase or decrease. Right now, that's not important. Let all the default setting remain there. Go for OK. And here, if you look at, this is Singapore Y1, and this is the construction 2-2. Singapore having 2 lags, BSc having 2 lags, China having 2 lags, and this is the constant term. If you have paid attention to, this is the system of equation which is being measured here. Yeah. Ditto same, only instead of 1 lag, that construction shows 2 lag. Right now, I won't go beyond this. I'll just show you how to, check the appropriate lag length. So there is a lag structure, and then there's one option in the lag structure, lag length criteria. So there I'll click. For argument's sake, I can give 10, I can give more also, but more than 10 will have too many terms, which is not recommended. Go for 10. And then what you will find is look at where the IAIC, it has already put the asterisk here. So what we are finding that the var of having 9th lag is giving you the least value of AIC. Again, you have got Schwarz information criteria. So that can also support other criteria are also there, but these two are AIC and SIC are the most popular one. SICs new, like your findings show us information criteria, ACAC information criteria. So 9, so by default, we have understood that when we are running the ARIMA VAR model, I'll go for 9 lags. Here I have. So I'll stop today. I'll take you from this as I meet on Tuesday or Wednesday. I just skipped with I'm meeting you again on Tuesday or Wednesday. And Sias, I have a very humble request. Don't make any request to change or reschedule the quiz, because when quiz is scheduled, so many things are planned. So we will be having a schedule. We'll stick to it. I'll check with Karkar that there is no conflict with any of your other schedules. Right? So can we close?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
You will meet next time and we'll have quiz also. The syllabus remains same for quiz, dummy variable and ARIMA. Though we have started VAR, VAR will go into other component of assessment. चलिए ठीक है.
Thank you, sir.
Bye.
Thank you, sir.